Study on effect of mixing eggshells with cement for improving characteristics of peaty clay. My name is M.D.J.P.Wickramasooriya. We did this research with M.D.S.W.Goonathilake. Peaty is highly organic soil consists of vegetative matter in varying conditions of decomposition. Geotechnical engineers face problems when constructing structures on soft peaty clays due to its long-term settlements and shear failure. Peaty clay is one of the most common problematic soils in Sri Lanka. In Sri Lanka, the most commonly used method to construct structures on peaty clay is open cut method and replacement method due to its simplicity for shallow depths. However, chemical and mechanical ground improvement methods are also used for deeper depths of peat layers. Therefore, it appears that there is a need to study the improvement methods for peat in an economical and eco-friendly manner. In addition, waste disposal is an environmental problem that increases year by year in Sri Lanka. Therefore, usage of waste materials for construction purposes is a relief to the environmental pollution also. This study focuses on the effect of mixing eggshells in wet and dry cement mixing for improving the characteristics of soft peaty clay. The main objective of this experimental research is to determine the optimum engineering properties of peaty clay by mixing with different percentage of eggshell powder with 15% of cement. The properties of the peat soil were determined by mixing 15% of the cement by weight with increasing percentages of eggshell powder as 10, 15, 20, and 25%. And the other engineering properties, the tests for the engineering properties were carried out for the untreated peat specimens as well as for the cement and eggshell powder treated specimens. Firstly, the soil sample was passed through number 4 sieve. Then the organic content test, moisture content test, specific gravity test, standard Proctor compaction test, modified Proctor compaction test, direct shear test, and CBR tests were carried out for the initial properties of the natural soil sample. According to the test results, the soil sample was identified. Eggshells were collected and thoroughly washed from the distilled water. Then they were grinded to make eggshell powder. The eggshell powder was passed through number 120 sieve. After that, peat was mixed with 15% of cement percentage and 10, 15, 20, and 25 eggshell powder contents by the dry soil weight. The peaty clay samples used in this study were collected from Orugodavatta in Sri Lanka, in the Western province. They were in slurry form and consisted mostly of the roots, wood pieces, and stones. The collected samples were black, clay, and had the typical smell present in the peat soils. Approximately 400 number of eggshells were collected from 2 restaurants in Wadduwa town in Sri Lanka. They were washed well and sun-dried for 3 days. Dried eggshell waste was grinded using kitchen grinder and then passed through the sieves. About 4 kilograms of eggshell powder was prepared. The peaty samples with smaller particle size were collected for tests because of the availability of larger surface area for fast and more effective chemical reactions. These are the laboratory tests that we conducted. Most of them were according to ASTM standards and 2 were as per the BS standards. The general properties of the peat soil were determined as follows. According to these results, the soil sample was the soil sample that was used was identified as a peat sample. Figure 3 illustrates the variation of specific gravity. All the samples with increasing eggshell powder percentage by weight. A specific gravity decreases for treated soil samples when the eggshell powder percentage increases. However, all the treated samples obtain increased specific gravity value more than that of the untreated sample. The variation of the maximum dry density and the optimum moisture content of all the samples are presented in this figure number 4. The maximum dry density increased and the optimum moisture content decreased with the increasing ESP content up to 20% by weight, but at 25% ESP content, maximum dry density decreased and the optimum moisture content increased to the nearest values obtained for the untreated peat. 65% peat plus 20% ESP plus 15% cement gives the peak value for the maximum dry density and the value for the optimum moisture content. However, the maximum dry density decreases when ESP content was increased beyond 20% as a result of large water absorption by unreacted eggshell powder in the peat cement ESP mix. Eggshells were used in powder format so that it had large surface area to contact with water. Therefore, higher moisture content was needed to achieve the MDD of the sample result in increased OMC. The shear strength properties of peat had increased in the range of 20 to 25% ESP percentage with 15% of cement, result in maximum angle of internal friction of 43. The main compounds of cement which contributes for the strength gaining are tricalcium silicate and dicalcium silicate to react with water and produce calcium hydroxide as in equation 1 and 2. Peat soil enriched with carbon dioxide, and thus when peat is mixed with cement and water, carbon dioxide react with CaOH2 produced. Therefore, calcium carbonate is supposed to produce from that reaction as in equation number 3. The dominating compound in the eggshell is calcium carbonate. Adding eggshell powder for this peat cement mixture would result in higher calcium carbonate percentage. Hence, this is one of the reasons that the shear strength of the peat samples mixed with cement and eggshell powder was improved. According to the above table, the CBR value of the mixture of peat plus cement plus ESP sample shows 3.7 times higher than the untreated peat. The considerable increase in CBR may be due to the binding action of the high percentage of cement and ESP on the peat. Higher maximum dry density and increased calcium carbonate content could have increased the interparticle bond. Consequently, CBR value might be increased. This is the summary of the test results that we have obtained. The test results with the eggshell for the different contents of the eggshell powder. You can see the summary here. 20% of eggshell powder by weight and the 15% of the cement by weight with balanced 65% natural peat mix sample obtain the most appropriate results or the optimum results. Maximum dry density obtained a considerable increase up to 20% of eggshell powder by weight, then decreased at 25% of ESP by weight. Specific gravity of treated samples decreased with the increase of ESP percentage with 15% of cement by weight. But the specific gravity of all the treated samples had been increased more than that of the untreated sample. Highest angle of internal friction was reached for 20%, 25% of ESP and 15% of cement and balanced 65% and 60% peat respectively. CBR was increased, CBR value was increased for 65% peat and 15% peat cement plus 20% of ESP mixed sample compared with the untreated peat. Here is the list of references that we have referred. Thank you very much.